Hi class, what I want to do in this video is walk you through problem number 12 on your homework this week. So this problem deals with the sampling distribution of the sample mean, much like the previous two problems in your homework. Okay, let's jump right into it. So the shape of the distribution of the time required to get an oil change at a 10-minute oil facility is unknown. So I don't know if it's right skewed, left skewed, normally distributed, I have no idea. However, records indicate that on average, the mean time here is 11.2 minutes, so it's not really a 10-minute oil change on average, but that's okay. And the standard deviation is 4.8 minutes. So let's compute parts A through C here. So to compute probabilities regarding the sample mean using the normal model, what size sample would be required? Well, so the central limit theorem tells us that regardless of the shape of the population distribution, so we don't know what it is up here because it's unknown, right? The sampling distribution of the sample mean will be normal as long as the sample size is greater than or equal to 30. So we got it. Good. All right, what is the probability that a random sample of n is equal to 35 oil changes results in a sample mean time of less than 10 minutes? Okay, so basically I'm going to take 35 oil changes at random, and I'm going to compute the mean of those 35 oil changes at this business, and I want to know, hey, well, what's the probability they came in under 10 minutes? Well, like we've been doing throughout the homework this week, you're going to load up your stat crunch, and you're going to want the stat calculators, you're going to want the normal calculator. So what you have to put in here is some mean and standard deviation. All right, well, we know that the sample or the mean, excuse me, sorry for starting there. The mean of this distribution of the sample means is the same as the population, which is 11.2 minutes. So I'm going to change that to 11.2. Well, I need to figure out what to put in here, okay, this standard deviation. Well, that's going to be the standard error. And all that is equal to for this distribution is you take the population standard deviation, which is 4.8 minutes, and you're going to divide it by the square root of the sample size, which is the 35 oil changes. And we're going to get 0.8113, and I'll round that to 5. So I'm going to take that now, what I just got, that's 0.81135, plug it in for the standard deviation. And I want it to be less than 10 minutes. So I'm going to hit compute. So this said now, take the probability out 4 decimal places, so it's going to be 0.0696 when I round it. Great, we got it. Okay, now let's take a look at part C. So suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. Great. On a typical Saturday, the oil change facility will perform 35 oil changes between 10 a.m. and 12 p.m. By treating this as a random sample, there would be a 10% chance of the mean oil change time being at or below what value? Okay, so this will be the goal established by the manager. So they want to make it really hard to actually get the bonus. So there's a 10% chance of being at or below a mean oil change time of blank minutes. It's actually pretty straightforward if you figure out what's going on here. I want to figure out what time, okay, will have only a 10% chance of being less than. So I'm going to change the probability here to 0.10, and then I'm going to hit compute. And they wanted this to the first decimal place, so it's going to be 10.16, so that's going to round it to be 10.2. And we got it. All right, class, I hope that helped.